You know that each and everything is made up of atoms. All right? Everything is made up of atoms. Book, pen, duster, stars, planets, plants, everything is made up of atoms. This marker, you, me, right? Atom. Now, the size of an atom is very small. I told you in the beginning that at the tip of a needle, imagine a needle, and where is it ending? Its tip. So at the tip of a needle, there would be at least 1 lakh atoms. So what would be the size of a single atom is? Okay, very, very small. In that atom, we know that there are certain particles. There are many particles, but we'll talk about, according to our syllabus, only 3 fundamental particles: electron, proton, and neutron. Okay? If an atom has 1 proton, then its name is hydrogen. If it's 2 protons, its name will be helium. 3 protons, lithium, 4 beryllium, 5 boron, 6. If an atom has 6 protons in its atom, we call it carbon. If an atom has 7 protons, we call it nitrogen. If you find an atom which has 8 protons, we call it oxygen, and so on. Okay? It means as the number of protons changes, the name of the element also changes. Clear? So this is very important. So the number of protons is called atomic number. Number of protons is called atomic number. And atom of carbon has 6 protons. So what is the atomic number of carbon? 6. An atom of sodium has 11 protons. So what is the atomic number of sodium? 11. One thing over. Second, in the nucleus of an atom, we can find protons and neutrons. Okay? If you add protons and neutrons present in the nucleus of an atom, then this will be called its mass number, which is roughly called atomic mass. There is a little bit difference between atomic mass and mass number. You will study afterwards. Okay? So what am I trying to say? Suppose we have an atom in which we have 4 protons, okay, and 5 neutrons. We have an atom, is the nucleus. It has 4 protons and 5 neutrons, and some electrons are revolving around it. Can you count how many electrons I drew over here? 1, 2, 3, 4. So what? Here I write that this contains 4 protons, 4 electrons, and 5 neutrons. Okay? What could be the name? 4 proton, if you see that periodic table, then an atom with 4 protons is called beryllium. So this is an atom of beryllium. Okay? So mathematically, what can you see here? That the protons and electrons are equal. Okay? So how will we write this? Beryllium 4 and 9. 4 will represent what? The atomic number, which is 4 in this case, and 9 will represent what? The mass number, which is 9 here. So this is general. When you see a symbol with 2 numbers written, then the smaller number always represent what? It always represents the atomic number. And the bigger number represent what? The mass number. One thing. Second thing, can you see a charge over here? It's written, look at the book. It's written like this. Is there any charge? No. Why? Because here the protons and electrons are equal. we have 4 protons here and 4 electrons here. It means this is electrically neutral, carrying no charge. All the atoms, all the normal atoms are electrically neutral, having same number of protons and electrons. If an atom of carbon is there, it has 6 protons, then it is understood it has 6 electrons. One thing is clear, that in an atom, electron and protons are equal. That is why it is neutral. Now the next question is there any possibility to change this balancement, to disturb this balancement? Yes, scientists have done it. They disturb this balancement. They can add or subtract electron. They can add or subtract electron. Look at the board. If you remove an electron over here, then this will be unbalanced. How will we show it right now? We will show right this, that beryllium is different from this beryllium. Why? Because one of its electron has taken away. So it has got a charge. What kind of charge? Positive charge. So when you see a charged atom, we simply called it an ion. So what is an ion? If you see a charge on an atom, then that charged atom is technically called an ion. And if you see a positive charge, then this type of ion is called a cation. Cations are positively charged. On the other hand, let's take another example. Might be the example of nitrogen. So how many of you could understand that what is 7 here? 7 is the Z value. A is the, what is the value of A? 14. And it has 7 protons and 7 electrons, since it is neutral. What is the condition right now? This is the condition. 7 protons, 7 electrons, electrically neutral. We write it like this. Now what happens? This nitrogen has the capability to gain electron, to accept electron. Let's suppose it has just taken from somewhere 1 electron or 2 electrons. Now there is the unbalancement. We will not write after taking electron and like this, but we will write n minus. 1 minus means it has absorbed 1 electron. Suppose it accepts 2 electrons, we should write here 2. Okay, so now this nitrogen is not neutral. This nitrogen is not neutral. It is carrying a charge, so it has become ion again. But since it is carrying a negative charge, that is why this is called anion. So what have we just revised? That a neutral atom has equal number of protons and electrons. Point number 2, an atom can gain or lose electron. If it loses electron, it will acquire a plus charge due to unbalancement and become an ion. Positively charged ion is called cation. On the other hand, if an atom gains an electron, it will acquire a negative charge. Charge acquiring, that is negative charge. Charge is there, it means it has become an ion. Negative means it will be called anion. Okay, so what is the definition of ion? A species, a thing, an atom, you can say, which carries a plus or minus charge due to the unbalancement of protons and electrons. Then we have seen a list of various cations, various anions. Let me write on the board.